In this problem, you're asked to graph this equation. And this equation is interesting because it's an absolute value equation, but you can't do your some normal absolute value things because there's this x outside the absolute value. So the best way to do this is to create what is called a piecewise function, or at least a good way to do it is to create this. I'm not sure it would be considered the best way. So what a piecewise function does is it recognizes that inside the absolute value, when the x value, whatever the x value is that makes the absolute value equal to 0, signifies a change in the graph. And if there's only one absolute value, then there's only one change, and the intervals are from -infinity to 1, because 1 makes this absolute value 0, and then 1 from 1 to infinity. So we create this interval and we say, okay, the first part of the graph goes from -infinity to 1, and then the second part of the graph goes from 1 to infinity. And then what you do is, to create the piecewise function, you actually have to think about what the absolute value is for that interval. And in the interval -infinity to 1, your values for the absolute inside the absolute value are always going to be negative. So to get the actual value, you need to take the opposite of that, -x plus 1. Because if an absolute value is negative, then the answer, or the evaluation of it, is the opposite. And so you do the opposite. And then you do plus 2x minus 4. And then for the second interval, well, inside that interval, the absolute value is always positive. And so it's just like the absolute value isn't even on there. And you get x minus 1 and then plus 2x minus 4. We simplify both of these and get x minus 3 for the top one. And for the bottom one, we get 3x minus 5. So what this means is that the first part of the graph, from -infinity to 1, the graph is a line that has a slope of 1, and from 1 to infinity, the graph is a line that has a slope of 3. The next step is the key step in making these problems a lot easier, and that is finding out what the point is where these two graphs meet. And they do actually intersect each other at this specific point, and that happens when x equals 1. So if x equals 1, then you get y equals -2. So at 1, -2, these two graphs meet, so you graph the point 1, -2. Now, for the first part, you have a slope of 1. Well, a slope of 1 just looks like this. Down 1 to the left 1, down 1 to the left 1. So that line has a slope of 1. Notice the y-intercept there is -3, which fits in with the y equals x minus 3. Okay, it just doesn't extend past x equaling 1, because once x equals 1, then we go to this graph, which has a slope of 3, so up 3 over 1, up 3 over 1, up 3 over 1, and so on and so forth. And then we extend our line through those points, and we get our graph. Again, notice if we were to go down 3 over 1, we'd get a y-intercept of -5, which also corresponds with that. So the graph of this absolute value equation looks like this. Notice it doesn't create that normal v we see with the absolute value, and that's because this 2x up here dictates that the slope of this is always positive, because the 2x is greater than the x. So even when the x was negative, it still resulted in a positive value in front of the x.